Hey everyone, and welcome back to the channel. Today, we're tackling a fundamental concept in React that often confuses developers. What exactly happens when React re-renders? You hear the term tossed around a lot, especially when talking about performance, but do you really know the intricate dance that unfolds behind the scenes? Let's demystify it. First off, what is a re-render? In simple terms, a re-render is when React calls your component function again to get a new description of what should be rendered on the screen. Think of it like a chef looking at a recipe, then looking at it again with updated ingredients. The chef doesn't necessarily cook the whole meal from scratch, but they re-evaluate what needs to be done. Importantly, a re-render does not automatically mean the browser's actual DOM will be updated. That's a crucial distinction we'll explore. So, what triggers these re-renders? The most common culprit is a change in a component's state. When you call a state updater function like setCount of count plus 1 from useState, React schedules a re-render for that component and its children. Similarly, if a parent component re-renders, it will trigger its child components to re-render as well, cascading down the component tree. This is a significant point. Even if a child component's props haven't technically changed, if its parent re-renders, the child will re-render too by default. Other triggers include changes to props received from a parent, changes in a context provider's value, or, less commonly, a forced re-render using a key prop change on a component. When a re-render is triggered, React enters what's known as the reconciliation phase. This is where the magic of the virtual DOM comes into play. React doesn't directly manipulate the browser's actual DOM element by element. That would be incredibly slow and inefficient. Instead, it maintains an in-memory representation of the UI, which we call the virtual DOM. During reconciliation, React constructs a brand new virtual DOM tree, representing the latest state and props of your components. It then compares this new tree with the previous virtual DOM tree. This comparison process is done using a highly optimized diffing algorithm. React's diffing algorithm is incredibly smart. It identifies exactly what has changed, whether a text node has updated, an attribute has changed, or a component has been added or removed. It doesn't rebuild the entire UI. It pinpoints the minimum necessary changes. Once React has identified these discrepancies, it moves into the commit phase. This is the only phase where React interacts with the browser's actual DOM. It takes all the identified changes from the diffing algorithm, batches them together, and then efficiently applies those updates to the real DOM. This batching is key to performance. Instead of making individual slow DOM manipulations, React makes a single optimized update. So, if your component re-renders but the virtual DOM comparison shows no actual changes to the rendered output, then no DOM updates will occur. That's why simply re-rendering isn't always a performance killer. Now, while React's reconciliation process is incredibly fast, unnecessary re-renders can still impact performance, especially in complex applications with many components or expensive calculations. This is where optimization techniques come in. The most common optimization is React.memo for functional components, or pure component for class components. These higher-order components will prevent a component from re-rendering if its props haven't shallowly changed. It's like telling React, hey, if the inputs are the same, don't bother rerunning this function. You also have useCallback for memoizing functions and useMemo for memoizing values, which are essential when passing props down to memoized child components, preventing them from re-rendering due to new function references or recalculations. Understanding re-renders also helps you grasp the impact of the context API. When the value provided by a context provider changes, all consumer components that subscribe to that context will re-render, regardless of whether their specific part of the context value actually changed. This can sometimes lead to widespread re-renders, so it's something to be mindful of when structuring your context. Finally, how do you even know when and why components are re-rendering? The React developer tools have a profiler that can visualize re-renders. You can also use libraries like why-did-you-render, which is fantastic for pinpointing exactly what caused a component to re-render in development. These tools are invaluable for debugging performance issues. In conclusion, React re-rendering is a core mechanism that makes React so powerful and declarative. It's not inherently bad, it's how React keeps your UI in sync with your data. The key takeaway is to understand the triggers, appreciate the efficiency of the virtual DOM and reconciliation process, and know when and how to apply optimizations like React.memo, useCallback, and useMemo to ensure your application remains snappy and responsive. Don't prematurely optimize, but when you notice slowdowns, a deep dive into your re-renders is often the first place to look. If you found this explanation helpful, please hit that like button, subscribe for more React insights, and let me know in the comments what other React topics you'd like me to cover. Thanks for watching, and I'll see you in the next one.